There is a piece of granite sitting in a glass case in London that should not exist. It is small, about the size of a soda can, dull gray and pink, chipped at one end, unlabeled in any way that would make you stop. Most people walk right past it, but run your thumb along the side of that stone, and you feel something that has been quietly breaking archaeology for over 100 years. A groove, a single continuous spiral, wrapping around the granite like the thread of a screw. It is not a scratch. It is not weathering. It is the signature left behind when a rotating cutting tool sinks into rock and pulls its way down. That stone is the waste product, the plug of leftover material that drops out of the middle when you drill a hole through something. Any machinist alive would recognize it instantly because they make them every day. The difference is that this one came out of the ground next to the pyramids at Giza, and the hole it came from was cut into red granite, one of the hardest building stones on the planet, at a time when the Egyptians are supposed to have had nothing harder than copper. Copper does not cut granite. Copper is softer than the quartz crystals inside the granite. Pressing copper against granite is like pressing a stick of butter against a cheese grater. The butter loses. And yet, the hole exists. The core exists. And the man who found it was not a mystic or a treasure hunter. He was the most careful, most obsessive, most mathematically ruthless surveyor Egypt has ever produced. And when he examined this piece of stone, he did something that historians almost never do. He calculated the cutting speed. What he got back was a number so impossible that for the next century, every explanation offered has fallen apart under testing. And this core is not the only one. There are hundreds of these objects scattered across Egypt. Holes cut in the wrong direction. Cuts that overshoot and keep going into stone that was never meant to be cut. Saw marks curving through granite in perfect arcs. Boxes buried under the desert that are flatter than the surface plates in a modern machine shop. Somebody in Egypt was cutting hard stone with something we have not identified. And the deeper you go into the evidence, the worse it gets, because the oldest examples are the best ones. The technology does not improve over time. It degrades. We are going to walk through exactly what was found, who found it, what the numbers actually say, and why one specific chamber underneath the sand at Saqqara has become the single most uncomfortable room in Egyptian archaeology. There is a measurement taken inside that chamber that nobody has been able to replicate, and nobody has been able to refute. And by the end, you are going to understand why the official explanation still has a hole in it that nobody has managed to fill. Let us start with the man who found the core, because the whole story depends on whether you can trust him. His name was William Matthew Flinders Petrie. He arrived in Egypt in 1880 with a set of surveying instruments he had built himself, and an obsession with accuracy that bordered on illness. He is the reason modern archaeology exists as a discipline. Before Petrie, digging in Egypt meant hauling out gold and smashing whatever was in the way. Petrie invented the idea that the broken pottery mattered more than the treasure. He invented sequence dating. He measured the Great Pyramid to a level of precision that survey teams with lasers have since confirmed. This is not a man who exaggerated. This is a man who went to Egypt specifically to disprove a popular theory about pyramid mysticism, measured everything himself, and published the numbers that killed it, even though his own father was a believer. So when Petrie picked up a piece of drilled granite at Giza in the winter of 1881 and wrote that the tools used to make it were beyond anything the ancient Egyptians should have possessed, that carries a different weight than it would coming from almost anyone else. The object is cataloged today as UC1 6036 in the Petrie Museum of Egyptian Archaeology in London. Petrie himself numbered it Core 7. It came from a tubular drill hole in granite at Giza. One end is wider than the other, roughly 16.3 centimeters around at the top, and 14.3 at the bottom, which means the hole tapered it got narrower as it went deeper. That taper is important, and we will come back to it. Here is the first clue, and it is the one you can see with your own eyes. Petrie described the surface of that core as carrying grooves that spiral around it in a continuous line. Not random scratches, not a rough abraded finish, a regular repeating helix, the way a screw thread runs. He noted the same thing on other drilled granite at Giza. And in a separate study of Egyptian materials published decades later, the chemist Alfred Lucas documented cores carrying as many as 17 equidistant spiral grooves. 17. Evenly spaced, wrapping around a cylinder of granite. For decades, scholars dismissed this as symbolic of nothing at all, just tool chatter. Random marks left by loose sand grinding under a copper tube. That is the standard model, and it is not a stupid one. We will test it properly later, because it deserves that. But Petrie did not stop at describing the grooves. He measured the distance between them, and that is where the entire thing detonates. The spacing told him how far the drill had descended with each full rotation. He calculated it at roughly 1/10 of an inch per revolution, 2.5 millimeters into solid granite in a single turn. Sit with that number. To cut 2.5 millimeters into granite in one rotation, you need enormous downward force, combined with a cutting edge hard enough to fracture quartz. Petrie ran the arithmetic on the pressure required and concluded the load on that drill would have been well over a ton. He then made the observation that has haunted Egyptology ever since. He wrote that only a handful of substances on Earth were hard enough to do this work, and he listed them: beryl, topaz, chrysoberyl, corundum, diamond. The Egyptians of the 4th dynasty are not supposed to have had any of them mounted in a rotating tool under a ton of pressure. Petrie was not proposing lost civilizations. He was an engineer looking at a workpiece and reverse engineering the machine that made it. And the machine he arrived at did not fit the century he was standing in, let alone the one the core came from. That is the first clue. Now here is the second. And this one you cannot explain with sand, because the drilling is only half of it. The other half is the sawing. Scattered across Giza, Abu Sir, and Abu Rawash are granite blocks carrying saw marks, long straight curves where a blade went into the stone. Some of these are unremarkable, but some of them curve. The cut arcs through the granite in a smooth radius, which is what happens when a large circular blade rotates into material, not what happens when two men drag a straight copper strip back and forth across a block. And then there are the overcuts. An overcut is a mistake. It happens when a cutting tool goes past the line it was supposed to stop at and keeps cutting into stone that was never meant to be touched. You see them in modern granite shops constantly. They are the fingerprint of a powered tool with momentum, a tool that does not stop the instant a human decides to stop. There is a famous one on a block at Giza where the saw clearly ran past its intended stopping point and bit into the adjacent surface, leaving a deep gouge in the wrong place. Somebody made an error, and the material recorded it. That is not ritual. That is not symbolism. That is a bad day at work, 4,500 years ago, preserved in stone. Now, think about what an overcut implies about the operator. You only overcut when your tool is removing material faster than you can react. Nobody overcuts with a hand-dragged copper strip and wet sand, because that process removes about the thickness of a sheet of paper in an hour of hard labor. You would have to fall asleep for a week to make that mistake. And there is a detail about these saw cuts that makes the standard model harder to hold. To cut a block of granite with a copper blade and sand, the blade has to be longer than the block. A 4-meter block needs a blade well over 4 meters long, dragged by a team, kept under tension, kept perfectly aligned so it does not wander and bind in its own slot. Copper at that length has almost no rigidity. It sags under its own weight. Keeping it straight through a cut that takes weeks is a problem nobody has demonstrated a solution to. Now, consider the sarcophagus inside the Great Pyramid itself. It sits in the king's chamber, cut from a single block of granite, and it is too wide to fit through the ascending passage. It was placed inside while the pyramid was being built, and it has been in that room ever since. Petrie examined it and found saw marks on the outside where the cut had run past its line, and drill marks on the inside where the mass of stone was hollowed out. The tool marks on the most famous stone container in the world are the same marks you find on a granite block in a modern yard. That is the second clue. And if you have made it this far, subscribe, because the third clue is the one that pulled aerospace engineers into Egyptology, and it is measurable to the 10,000th of an inch. 16 kilometers south of Giza, at Saqqara, there is a hillside that in 1850 was nothing but sand and a few stone heads poking out of the dunes. The French archaeologist Auguste Mariette started digging there because of a line in an ancient text describing an avenue of sphinxes. He found the avenue. He followed it, and it led him to a sealed entrance in the rock, and behind that entrance, a tunnel. The tunnel goes down into the bedrock and then runs for hundreds of meters in the dark. Cut into the walls on both sides are side chambers, spaced at intervals, each one carved out of the living rock like a garage bay. And sitting inside those chambers, 24 of them, are the objects that have never stopped causing trouble. They are boxes, enormous ones, each carved from a single block of stone, roughly 4 meters long, 2.3 meters wide, and 3.3 meters tall. Each weighs between 70 and 100 tons. On top of each sits a separate lid cut from the same material, weighing around 30 tons on its own. Most are rose granite from Aswan. That quarry is about 800 kilometers up the Nile. Some of them are not granite at all. Some are a harder stone still, quarried from even farther away. Stop there for a second. Somebody quarried a 100-ton block of granite 800 kilometers away, moved it north, brought it down a shaft into an underground tunnel, maneuvered it around corners into a side chamber with almost no clearance, and then lowered a 30-ton lead onto it in a space where you cannot stand behind it and push. And they did it 24 times. Mariette's own account of what happened when he got inside adds a layer that people rarely mention. He found the boxes already open, lids shifted aside, interiors emptied. Somebody had been down there before him and had gone to the enormous trouble of moving 30-ton slabs of granite in a confined underground chamber, in the dark, and then left. Whatever they came for, they took. And in the corridor above one of the chambers, Mariette recorded finding a workman's handprint pressed into mortar and the marks of the last person to leave before the site was sealed. The kind of detail that collapses 4,500 years into nothing. Now, the official explanation for these boxes is that they held the mummified bodies of sacred bulls. That is the standard reading, and there is real textual support for the site being connected to a bull cult. But hold that thought, because when engineers started measuring the boxes themselves, the story got complicated in a way nobody expected. In 1995, a man named Christopher Dunn went down into that tunnel. Dunn was not an archaeologist. He was an aerospace manufacturing engineer who had spent his working life around precision machining, the industry where parts are rejected if they are wrong by the width of a hair. He brought a precision straight edge, he climbed inside 2 of the boxes, and laid the edge against the interior walls, checking for light underneath it, which is the oldest and most reliable flatness test there is. He found the interior surfaces flat to within 2/10,000ths of an inch. That is a tolerance you would expect from a granite surface plate. A surface plate is the reference object in a machine shop. It is the flat thing you measure everything else against. Modern ones are lapped by machine over many hours with progressively finer abrasives, and they cost a fortune. Dunn went back in 2001 with a precision square calibrated to 500,000ths of an inch, and checked the corner where the interior wall meets the top surface. Within the resolution of his instrument, it was square. 90 degrees. Not 89, not 91. And the interior corners, where two walls meet, have a radius of roughly 4 millimeters. A tiny, consistent fillet running the height of the box. That detail is easy to skip past, so let me explain why it matters. A sharp interior corner in granite is very hard to produce. A small radiused corner is what you get automatically when a rotating cutting tool with a rounded edge runs down into the join. It is not decorative. It does nothing for a viewer. It is exactly the artifact a machine leaves behind. So, you have flatness, squareness, and parallelism achieved simultaneously across interior surfaces several feet across. Inside a box that had a 30-ton lid dropped on it and was then buried in a tunnel in total darkness where nobody would ever look at it again. Here is where it gets strange. Nobody has replicated those measurements. Nobody has published a refutation of them. Nobody in 30 years has gone back down with better instruments and settled it. The most controversial engineering claim in Egyptology, and the response has been silence. And there is a second thing about those boxes that is harder to talk away. The precision is on the inside and the outside surfaces. The hieroglyphs, where they exist, are on some of the boxes, and they are crude, roughly hacked into that mirror finish, shallow and uneven, clearly done later, and clearly done by somebody with worse tools than whoever made the box. Two different levels of skill on the same object. One of them so good, we cannot replicate it. One of them so bad, it looks like graffiti. That pattern repeats everywhere in Egypt once you start looking for it, and the direction it runs in is the opposite of what history is supposed to do. Which brings us to the artifacts that started this whole argument long before Petrie or Dunn ever set foot in the country. Beneath the step pyramid at Saqqara, in a set of galleries cut into the bedrock, excavators found a horde of stone vessels. The number is staggering. Tens of thousands of them packed into the underground chambers, carved from a range of hard stones, including granite, diorite, and rock crystal. They are older than the pyramid above them. Many are pre-dynastic or early dynastic, which means they were already ancient artifacts when they were stored down there, collected and sealed underground like a museum inventory. Some of these vessels have walls thinner than a coin. Some have narrow necks that open into wide hollow bodies, which means whatever cut the interior had to go in through a small opening and then widen out inside, working blind. Some are carved from stone, hard enough to scratch steel. In recent years, people have started running these vessels through the same equipment used to inspect turbine blades: structured light scanners, coordinate measuring, producing point clouds accurate to microns, and then running the geometry against a mathematical model. The results reported from some of these scans describe near-perfect rotational symmetry, wall thicknesses holding steady around a curve, surfaces that fall onto a defined axis, with deviations measured in fractions of a millimeter. Now, this is contested hard, and I want to be honest about that, because the loudest claims in this area have outrun the data more than once. The sample sizes are small. Some vessels, scanned as spectacular examples, turned out to have looser tolerances on closer inspection. Provenance is often unclear, and a vessel with no excavation record is a vessel that cannot carry an argument. But the core observation survives the deflation. The pre-dynastic hard stone vessels are, on average, better made than the ones produced 1,000 years later. The skill peaks early and then falls off. And there is a practical problem with the vessels that has never been solved. To hollow a wide belly through a narrow neck, your tool has to bend or articulate or expand once it is inside. A straight drill cannot do it. A handheld pick cannot reach the underside of the shoulder. Whatever went in through those openings had to change shape or direction after entry, and then remove material evenly across a surface the operator could not see, holding a wall thickness of a few millimeters all the way around. Get it wrong by a fraction, and the vessel cracks and weeks of work become gravel. They made tens of thousands of them. That is backwards. Technology accumulates. It does not usually arrive fully formed and then decline. When you see a capability appear at its maximum and degrade afterward, what you are normally looking at is something inherited rather than developed. A method that was already old when it shows up in the record. And that is the question underneath all of this. Not who built the pyramids, something narrower and much harder to dodge. What were they cutting with? Here is where the honest part comes in. Does any of this prove a lost advanced civilization, or visitors from somewhere else, or a forgotten global technology? No, it does not. And the people selling that certainty are getting ahead of the evidence. Because there is a conventional explanation, and it is not a weak one. In the 1990s, an experimental archaeologist named Dennis Stocks decided to stop arguing and start cutting. He built replica tools from copper using the alloys and forms actually found in the Egyptian record. He fed quartz sand under a rotating copper tube, and he drilled granite. It worked, slowly, expensively, with the copper wearing away far faster than the stone. But it worked. The copper tube does not cut. It carries. It drags loose quartz grains under pressure, and the quartz does the cutting. The tube is a delivery system, and it is consumed in the process. Stocks also produced striations. He documented marks around 1/4 millimeter wide and deep, and matched them against markings on genuine Egyptian artifacts, and on borers recovered from Mesopotamia. The marks lined up. The taper on Petrie's Core 7, the reason one end is wider than the other, has an obvious explanation in this model. The copper tube wears down as it descends. A tube that is thinning as it cuts produces a hole that narrows with depth, and a core that narrows to match. And the spiral itself has been challenged directly. The acoustics engineer John Reed and the stonemason Harry Brownlee physically examined Core 7 and reported that what looked like a continuous helix was in fact a series of separate rings, of the kind you find on cores pulled from any modern quarry. If they are rings rather than a spiral, Petrie's feed rate calculation does not apply because there is no thread to measure the pitch of. That is a serious objection, and it deserves to be stated at full strength. Dunn himself has acknowledged he never physically examined Core 7 before building his argument on it. So the grounded version goes like this. Egyptian craftsmen developed abrasive stone working to an extraordinary level over many centuries. They understood that the abrasive was the tool. They built jigs, weighted rigs, bow drills, and lever systems that applied and sustained pressure far beyond what a hand can manage. They organized labor on an industrial scale, with specialists who did one operation their entire working lives. They were not primitives. They were an advanced ancient industry, and we have been underestimating them because their machines were made of wood and rope and did not survive. That version is fascinating on its own terms. It does not need aliens to be remarkable, but that explanation has a problem. Stocks drilled granite. He did not drill it at 1/10 of an inch per revolution. Nothing anyone has built has come close to that rate. The replication proves the method is possible. It does not reproduce the speed Petrie calculated. And nobody in 30 years has replicated the Serapeum tolerances. Not the flatness, not the squareness across a 5-foot span combined with parallelism on the opposing wall. Not with sand and copper, not with any experimental method. Not at all. No one has even identified what reference system the builders used, and that is the deeper problem. To make a surface flat to 2/10,000ths of an inch, you need something already flat to compare it against. To make 2 walls parallel across a 100-ton block, you need a datum, a master reference. Where is it? Where is the ancient Egyptian surface plate? Where is the straight edge? We have their copper chisels, we have their mallets, we have their drill sand and their bow drills and their sledges. We do not have a single instrument from ancient Egypt capable of verifying the tolerances that appear on their best work. The tools we have found cannot check the work we have found. That is not a gap in the ancient record. That is a gap in the explanation. And the boxes were buried. That is what makes it worse. A craftsman polishing a temple facade is making something to be seen, and precision is showing off. The Serapeum boxes were sealed in a tunnel under the desert. The interior surfaces were finished to machine shop standards and then closed with a 30-ton lid in permanent darkness. You do not do that for appearance. Appearance was not a factor. Whatever that precision was for, it was functional, and we do not know what the function was. If the tolerance was the point, then the boxes are not coffins. They are containers built to a specification, and a specification implies a purpose, and a purpose implies an industry, and an industry implies a body of engineering knowledge that is completely missing from the historical record. We have the products. We do not have the process. We have the finished parts of an ancient manufacturing capability scattered across 100 kilometers of desert, and we have not found the workshop. That is what the core in the London Museum case actually represents. Not a mystery about who built the pyramids, a missing chapter in the history of how humans learned to shape the physical world. Somewhere between the pre-dynastic period and the 4th dynasty, in the Nile Valley, people worked out how to cut the hardest stone available to a standard we struggled to match, used it on a scale involving hundreds of thousands of tons. And then the knowledge thinned out and vanished, leaving descendants who scratched crude marks into surfaces their ancestors had finished to a mirror. And if that is true, it means our history is missing a chapter, not a legend, a technical one, a chapter about what was known, by whom, and how it was lost. Here is the final question, and nobody has answered it. There are still boxes in that tunnel that have never been properly measured. There is at least one chamber, reported by people who have been down there, holding a box significantly larger than the 100-ton examples in a section closed to the public. The instruments to settle this argument exist and are not expensive. A laser scanner, a week underground, a published dataset. It has not been done, not once, in 30 years, in the most photographed archaeological landscape on Earth. Core 7 is still in its case in London, spiral grooves and all, and almost nobody who walks past it knows what they are looking at. The tunnel at Saqqara is still there, still dark, still holding 24 boxes that nobody has measured properly. The lids are still on, the corners are still square, and the workshop that made them has never been found. If you want to see what happens when the same kind of precision turns up somewhere it has no business being, watch the next investigation on screen now.